Okay guys, let's continue on in module 26201-23, alternating current in NCCR electricity level 2. This section will be 2.00 unknown values in AC circuits. Purely resistive AC circuits. Every AC circuit has a AC voltage source. AC voltage applied across an external load produces an alternating current of the same waveform, frequency, and phase as the AC voltage. In an AC circuit with only purely resistive loads, the current variations in the phase are in phase with the applied voltage. In purely resistive AC circuits, the voltage, current, and resistance are related by Ohm's law. The characteristic of an electrical circuit that opposes the change of current flow is called inductance. Inductance in DC circuits, a change must be initiated in the circuit to cause inductance. In AC circuits, the current is continuously changing and producing induced voltage. The ability of a conductor to self-induce voltage into itself when the current changes is referred to as self-inductance. Factors affecting inductance. There are several factors that affect inductance, such as these coils, the number of turns in the coils, the coil diameters, the length of the core material, or the winding in the coil in layers. Whenever there is an induced voltage, there is also an induced current. As voltage cycles between its maximum and minimum values, changes in the magnetic field will cause current flow in the direction opposite to how it is approached. The opposing force that an inductor presents to the flow of an AC is called reactance. Inductive reactance can be calculated using the following formula. XL equals 2 times pi times FL, where XL represents inductive reactance, F is frequency, and L is inductance. Capacitance is the ability to store an electric charge. When voltage is applied to a capacitor, it begins to charge. The capacitor will continue to charge until the potential difference across the capacitor is equal to the applied voltage. The capacitor can be discharged by creating a path across the dielectric material. Once discharged, there is no voltage or current across the dielectric material. There are several factors that can affect capacitance, such as the area of the plates, the distance between the plates, and the dielectric permittivity. Capacitors can be connected in parallel or series. Connecting capacitors in parallel is equivalent to adding plate areas. Connecting capacitors in series is like increasing the thickness of the dielectric material. A capacitor specification lists the capacitor's maximum voltage and temperature rating. The charge of a capacitor fluctuates with changing AC voltage. The charge on a capacitor varies directly with the voltage. Capacitors offer opposition to current flow. Capacitive reactance can be calculated using the following formula. XC equals 1 divided by 2 times pi times F times C, where XC is capacitive reactance in ohms, F is frequency in hertz, C is capacitance in farad, and then 2 times pi, which is 6.28, or 2 times 3.14. Combination circuits, AC circuits, often contain inductors, capacitors, and resistors in series and parallel. In purely resistive circuits, the voltage and current are in phase. In inductive circuits, the voltage leads the current by 90 degrees. In capacitive circuit, the current leads the voltage by 90 degrees. Impedance is the opposition to current flow in an AC circuit. Impedance can be calculated using the following formula, where Z equals impedance, R is resistance, and X is your net reactance. RL circuits combine resistors and inductors in series parallel or series parallel configuration. In an RL circuit, the current will lag the voltage by an angle between 0 and 90 degrees. In an RL series circuit, the higher the value of XL compared to R, the more inductive the circuit is. In an RL series circuit, the current lags the applied generator voltage. In a parallel RL circuit, the higher the value of XL compared with R, the more resistive the circuit is. The resistive branch has the same phase as the applied generator voltage. The inductive branch current lags the applied generator voltage by 90 degrees. RC circuits contain both a resistor and a capacitor. In an RC circuit, the current leads the voltage by an angle of less than or equal to 90 degrees. In a series RC circuit, the current is the same in both reactance XC and resistance R. In a series RC circuit, the higher the XC compared with R, the more capacitive the circuit. In a parallel RC circuit, applied voltage is the same across each branch. The branch voltages are equal and in phase. Branch current depends on applied voltage and resistance or capacitance contained in each branch. In a parallel RC circuit, the higher the XC compared with R, the more resistive the circuit. LC combination circuits can combine inductance and capacitance. The current in a series LC circuit is in phase and the same at all points. The voltage drop across the inductor leads the current by 90 degrees, and the voltage drop across the capacitor lags the current by 90 degrees. The impedance is either purely inductive or purely capacitive. In a parallel LC circuit, there is an inductive and capacitive load connected in parallel across a voltage source. In a parallel LC circuit, the voltages are equal and in phase. The currents in the branches are out of phase with the circuit voltage. The current in the branches of a parallel LC circuit depends on the value of the reactance in each branch. Circuits in which the inductance, capacitance, and resistors are all connected in series are called series RLC circuits. The current in a series RLC circuit is in phase and the same at all points. The voltage drop across the inductive and capacitive loads are 180 degrees out of phase. In a parallel RC circuit, the branch voltages are equal and in phase. The current in a parallel RLC circuit divides among the branches and is dependent on the voltage and the resistance or reactance combined in the branch. And there's a capacitive AC circuit. Some trade terms you should read over and become familiar with. And some review questions for this section. It says, what is the voltage in a purely resistive circuit with a current of 22 amps and a 10 ohm resistance? If I want to know E, cover E, I times R, I is 22, R is 10, 220 volts. Which of the following coils is likely to show the highest inductance? A coil with few turns, a coil with a non-magnetic core, a coil with a narrow coil, or a coil with a short core. So a coil with a short core. The total capacitance of 3 10 microfarad capacitors and 1 5 microfarad capacitor connected in parallel is, well, I think we'd add them together, 10, 20, 35. A circuit's impedance is represented by the letter I, R, X, or Z. A lot of people say R, but it's going to be Z. Okay, guys, that's it for that section. The next section in this will be 3.00, power in AC circuits, and I'll see you over there.